The reason behind why this is Si in terms of identity matrix is because it can be any variables. Alright, it can be any variables. Can be 3, can be 2, can be 1, can be 10. Alright, it can be any of this. But it can also be multi-variables. And therefore, if it's a multi-variables, then you're talking about S as a somewhat of a vector. Alright, S is somewhat of a vector. Or I can call S as, to be more exact, as lambda. Alright, the eigenvalue. But however, I'll not go into details on what is that, because if you take a look at Si, alright, Si minus A is equals to 0. If you take a look, for example, this is in fact the form of the finding of the eigenvalue, which in other words, S is lambda. Alright, but I'm just not going to go through this in the future. Then we will go through it. But however, the multivariable states that we will have S1 have a matrix. Perhaps you can say that this is 3 times 3. We can also have 4 times 4. We can have 5 times 5, 6 times 6, be it how many identity matrix you want to do. Alright? And therefore, if this is a 3 times 3 matrix, then likewise this whole chunk should be also in terms of 3 times 3. And in other words, A is also 3 times 3 matrix. Alright, by the matrix addition rule. Alright, in other words, this is minus away a certain matrix. Alright, this holding bracket. Alright, this is simply the case over here. So A can be some numbers of matrices, maybe 3 times 3 also, maybe 4 times 4, mainly based on how many 3 times 3 or 4 times 4 this is talking about. Alright, so if this is 3 times 3, then A will also be 3 times 3. That should be the same. This is the addition rule. Alright, addition rule for the matrices. Okay, and therefore you can continue to watch the rest of that video. Alright.